Hi guys, we've used characteristic properties to identify substances. Now we're going to use characteristic properties to separate substances. Most of the natural world is in the form of mixtures, heterogeneous or homogeneous mixtures. Most things are not all one substance. Nature supplies us with all sorts of materials to build the man-made world. Things like all these different metals that you're looking at here have to be brought out of the ground, and they certainly don't come out of the ground already separated and purified. We have to figure out how do I get the copper out of that rock? How do I get the iron out of the rock? How do I get the aluminum out of the rock? And it's not just metals, it's other stuff too. Here's something that comes out of the ground that you probably don't give much thought to where it comes from. This is oil, sometimes called crude oil or petroleum. And crude oil, petroleum, is a mixture that's very complex. There are hundreds of different things mixed together in the crude oil that comes out of the ground. And different places have different amounts of different parts of that mixture. So this is a heterogeneous mixture. It's not even a solution. It's not evenly mixed, and different locations around the world, different stuff is in their oil. How do we get useful stuff out of this? Because this is not useful at all, the way that it comes out of the ground. Well, we actually have to separate it into the different fractions that make it up that we do find useful. Stuff like gasoline, or tar, or asphalt, or kerosene, or petroleum jelly. All those things are mixed in here, but we have to get them apart before we can make them useful. Plus all the natural gases like methane and ethane and propane. And a whole bunch of those are used in the building or the creation of chemical reactions that produce plastics. So all of these things have to be separated from each other before we can actually make use of them. So let's look at the different techniques used for separating stuff. Here's technique number one. Pretty simple. If you suspect that your mixture contains something magnetic, a good thing to help you get the mixture apart would be to sweep it with a magnet. When you do this, you're going to want to cover your magnet with something so you don't get a whole bunch of bits and pieces of magnetic stuff sticking directly to your magnet. I recommend doing this with a piece of round filter paper, one of those coffee filters, and that way you have sort of a barrier between your magnet and anything it happens to pick up. I also recommend that when you do a magnetic sweep of a mixture, that you lay the mixture out nice and flat on a paper towel or a piece of paper and spread it out so that you can run the magnet over it several times back and forth, back and forth, back and forth, and pick up as much as you possibly can of anything that happens to be magnetic. Now, you don't have to know what you have to do this test. I always recommend that this be the first technique that you apply to any mixture, because if you do happen to have something magnetic in there, it's probably iron. There are a few other metals that are magnetic, including nickel and some alloys of iron like steel. So all of those things tend to rust if they get wet, and some of the other procedures you're going to do later on will get your substance wet, so you might as well do a magnetic sweep first. Get anything that's magnetic away from the rest of your mixture. So if you had a mixture of sand and iron filings, by the way, the word filings, I've mentioned this before, it's not fillings, it's filings, as in pieces that have been filed off with a file, like a nail file. So iron filings will come away from the sand using a magnet. Very convenient. Okay, next technique. Another cool technique to use is flotation. Just like what it sounds like, this is where you would add water to your mixture in the hopes that some of the items in your mixture will be less dense than water and will therefore float. You don't have to do this with water. You could actually do it with any liquid, and that will allow you to see if some of your stuff floats in, say, alcohol. Water has a density of 1.0 grams per milliliter. So if you have substances that are less dense than water, less dense than 1, they'll float to the top. And in this case, I have these little beads, these little plastic beads that are floating at the top of the water, and everything else that was in this mixture sank to the bottom. But let's say I had a mixture where I had everything was less dense than water, so it all wanted to float. Well, then I might want to pick a less dense liquid like alcohol, which has a density around 0.80 grams per milliliter, and see if I could get some stuff to float in my alcohol and other things to sink. So you have two liquids to choose from to try flotation. Since you don't always know what you have in your mixture, it's a good idea to take a tiny smidge of your mixture and add it to each of these two liquids to see, do I get some things sinking? Do I get some things floating? The other thing that'll happen is if you have a substance that dissolves in water or in alcohol, you may find that some of your mixture disappears on you. But remember, it's not gone forever, it's just dissolved. And you can actually use that to your advantage. So flotation uses the characteristic property density, and the previous technique uses the characteristic property of magnetism. The next technique uses the characteristic property of solubility. So you've added some water and you've stirred up your mixture and some stuff floated and you scraped it out. But also you noticed as you stirred up your mixture that it seems like you have less stuff than you did before. Some of your stuff apparently has dissolved. Well, now what do? Well, let's imagine that we had salt and sand and iron filings all mixed together. We took our iron filings out with our magnet, and now we had just salt and sand, and maybe those white beads were in there too, and we scraped them out, and now we're down to just salt and sand. Well, we could stir up this liquid, and all the salt should dissolve, leaving behind sand sitting on the bottom, which is great. We've just separated our salt from our sand, but we want to get that salt back. How do we do that? Well, we filter. We're going to pour that water through a funnel that has filter paper in it so that all of the water with the salt dissolved in it goes through and collects in an evaporating dish. Caught here in the filter paper will be the undissolved sand. So our sand is now separated from our salt water, and if we want, we can get rid of the water from our salt. That's the next technique. This technique is called distillation. So we have salt water. If we heat it over an alcohol burner, we'll find that the water particles can boil away, but the salt will not boil away at the temperatures we can create with our flame. So little by little, all the water will vanish, leaving us with a dish of salt. This is called a simple distillation, and it's simple because it involves getting rid of one liquid and not saving the liquid. That's a pretty simple thing. Sometimes you have a mixture of several different liquids, like the petroleum that we were talking about. Petroleum is a mixture of hundreds of different liquids, and the way that they get those apart is by doing a fractional distillation. Fractional means that there's different fractions or parts. So in the case of petroleum, what you do is you boil it, and each liquid boils away at a different temperature. You're going to do a distillation of two liquids in class during the next week. The liquids you're going to use are just water and alcohol. You're going to mix them together. Water boils at 100 degrees Celsius, and alcohol boils around 80 degrees Celsius. So what'll happen is, as you heat your mixture up, you'll find that your alcohol will turn to a gas during your 80-degree plateau. That's the temperature at which the alcohol particles are coming apart and turning to a gas. They'll leave the test tube, go through this tube, and when they get away from the heat, they'll turn back to a liquid, and you can collect that alcohol in the separate test tube. When that plateau breaks and you're no longer hovering at 80 degrees, that means that your water is all that's left, and your water is now heating up on its way to its boiling point. So after you've been at 80 degrees for a while, and you'll probably won't stay right at 80, you'll probably do something like 79, 80, 80, 81, 79, 81, like that. But you call that a plateau. When you jump up a significant amount, like to 85 degrees, 86 degrees, you know at that point, hey, all my alcohol's gone, because alcohol can't get up that high. It's already turned to a gas. So then that would mean that the only thing left in this test tube would be water. If you had more than two liquids, then you would want to just get a new test tube to collect your second liquid. But in this case, since we only have two liquids, when we're done fractionally distilling our water and alcohol, the alcohol will be over here, and the water will have stayed behind in the larger test tube. So there's two kinds of distillation: simple and fractional. Okay, so now what I want to do is I want to try to create what I call a flow chart for the separation of this imaginary mixture. I'm going to pretend that I have sulfur, citric acid, iron, and sugar all mixed together in a container, and your job is to get them apart from each other. To do this, you need to know what the characteristic properties are of the components. That makes it a lot easier. If you don't know what's mixed into your mixture, the problem becomes a little more difficult, and that's something we'll do in the next step. But for right now, you know what you have. So you want to go and research some of these properties. What are the characteristic properties of sulfur? What's its density? Is it soluble in water? Is it soluble in alcohol? Is it magnetic? Does it give off a particular color of flame, and so on? And same thing for citric acid, iron, and sugar. After you've gathered all of that information, now you can ask yourself, okay, which of the techniques that I've learned can I use to get this thing apart? Hopefully you realize that the first step here should be to pull out the magnetic substances. Magnetism is a characteristic property. There's only a few substances that are magnetic, and they have to contain one of the magnetic metals, and that would include iron, nickel, and cobalt. And I don't think there's another one. There might be, though. So the magnetic metals can be pulled out with a magnet doing a magnetic sweep. So we'll create our flow chart by putting a down arrow and then identifying the technique that we want to use. So that arrow represents our procedure that we want to apply to our mixture. We want to apply a magnetic sweep. And when we do that sweep, we'll get the mixture separated into two piles. On one side, we're going to have the magnetic stuff, and on the other, we're going to have the non-magnetic stuff. Now, we know what's in this mixture, so we can actually write down the names of the substances. But if we didn't know what was in it, if these were, instead of sulfur, citric acid, iron, and sugar, if they were just A, B, C, and D, then we would just say, okay, on the left-hand side, we'll get the magnetic stuff, and on the right-hand side, we'll get the non-magnetic stuff. But since we know the names of all these things, let's go ahead and put in what we'll get on each side. And there you go. On the left, we'll have our sulfur, citric acid, and sugar, and on our right, we'll have our iron. Since our iron is now separated from our mixture, I'm going to go ahead and box it in gold so that we can keep in mind we're done with that puppy. We don't have to do anything else. Now, the next thing that we want to do is figure out a separation technique we could use to get sulfur, citric acid, or sugar out. To do this, I need to know that some of these things dissolve in water and some don't. Sulfur, for example, is insoluble in water or alcohol, but citric acid and sugar both dissolve in water. So I think I'm going to filter. So I create an arrow and I pull up the procedure filter. And specifically, I want to filter using water because I don't have to use water. I could use alcohol also, and we will later on. So we're going to filter with water, and as a result, we're going to get, again, two branches to our flowchart. On one side, we're going to get our sulfur, which doesn't dissolve. And on the other side, we're going to get the citric acid and the sugar, which do. And there's one other thing that's now added to my mixture that I needed in order to do a filtration. I added water. And where does the water wind up? It goes through the filter paper with the citric acid and the sugar. So I have to put it on the right-hand side here. So now I have citric acid, sugar, and water. But I don't want that water to be there. I just want my citric acid and sugar. And I also need to separate the citric acid from the sugar, but I really can't deal with that till I get that water out of there. So I'm going to use a simple distillation. A simple distillation will boil that water away, leaving my citric acid and sugar behind. Now, there's only one thing I want you to be aware of. I did do this actually in the lab the other day, forgetting that sugar, when it gets hot, burns. And so this actually, distilling your water away from your sugar and citric acid will have to be done at a very low temperature, below the boiling point, so that the water evaporates without actually burning your sugar. But don't worry, when I give you your mixture, it won't have stuff in it that does weird stuff like that. So when you do this, you will get the water in one place. Let me move all our options out of our way. Get these these down here. Use those later. We're going to get water over here. You'll notice it's hard to write neatly on the iPad, which is why I've been typing. So when you're making one of these flowcharts, you should probably do it on paper, because unless you're going to type every single piece of it. So I'm going to get water over here when I distill, and hopefully if I don't burn it, I'll get back my sugar and my citric acid over here. So now what I need is a procedure that gets the sugar and citric acid apart. And since one is soluble in water and one is soluble in alcohol, I can actually use filtration again, but this time with alcohol. And this will separate my sugar, from my citric acid. Because my sugar will not dissolve. It'll stay behind in my filter paper. My citric acid will go with my water. And I'm running out of room, so I'm just going to do citric and water. What would be the last arrow, the one I haven't added, that has to go from citric and water, the citric acid and the water, to get the citric acid away from the water? What would be that last arrow? Think about that and bring that information to class with you. And I'll redraw this on the board, and that's how I'll start our first lesson on Monday, with this. We'll go through that, we'll review this tutorial together, and then we'll take the quiz. Because this is a lot of information, so I want to make sure that you really understand it. But you should still take some notes, and when you come to class, I'll answer any questions you have. See you guys then.